Hello, welcome to Slice of Physics. I'm going to tell you about maps, and in particular a kind of map called a number map, which will be useful throughout the course. So what is a map? Well, a map is just what you think it is. It's a way that we have of drawing a picture of an area of land, such as a city, a state, or a country. But I'm going to tell you about a kind of map, a special kind of map that's going to be very important to us, called a contour map. So let's say that we have some sort of mountain. Here's a mountain. And this is what it looks like from the side. And let's say that I want to draw this mountain from above. But if I draw the mountain from above, I can't see how tall it is. So this mountain, let's say, at this level is 9,000 feet tall. And at this level is 6,000 feet tall. And at this level is 3,000 feet tall. So how can I draw the mountain from above? Well, from above there will be an area that is 9,000 feet, and there will be an area that is 6,000 feet, and then below that there will be an area that is 3,000 feet. So this is just an a view from above of the mountain. And to make this into a number map, I'm going to draw numbers to show the height at different places. So this height is 3 for 3,000 feet above sea level. And at this level is 6,000 feet above sea level. And at this level is 9,000 feet above sea level. But I'm leaving out a lot of numbers because in between the 3,000 feet and the 6,000 feet, so up here, there's also a 4,000 feet level and a 5,000 feet level, right? So here there's a 4 and a 5. So if I want a complete picture, I should draw the 4,000 and 5,000 levels. And there's in between the 6 and the 9, there's a 7 and an 8,000 feet level. And then maybe at the very top of the mountain there's a 10,000 foot level. So maybe the top of the mountain is 10,000 feet above sea level. So I could draw more contours using these 4s and 5s. So there's a 4,000 foot contour, like this. And there's a 5,000 foot contour, like this. And there's a 7,000 foot contour, and so on. So, and of course in between the 4 and the 5, there's a 4.5 thousand foot contour. That's 4,500 feet. So there's lots and lots of numbers here that I haven't drawn. So that's a number map that is also a contour map. So in this case, the numbers represent the height of that part of the mountain. What else can the numbers represent? So let's suppose I have a map of a forest. So in this forest, there's an area of very dense trees, and I'll show the density by these dots that are filled in to show that it's very dense forest. And then around that, there's an area of less dense forest. And around that, there's an area of even less dense forest. So let's say that this represents 5,000 trees per square mile, and this represents 3,000 trees per square mile, and this represents 1,000. So then maybe over here there's some more forest, and some more forest, and some more or less dense forest. Okay, so I can draw contours. Let me draw these in a different color. So first let me draw the numbers actually. So here is 5,000 trees per square mile, and 3, and 5, and 3, and all this is 1. So again, the numbers now, instead of meaning the height, the numbers now mean the density of the trees. How close together and tightly spaced are the trees? So I can now draw contours. So here's a contour for the 5s, and over here there's also a contour for the 5s, and here's a contour for the 3s, and another contour for the 3s, and then it looks like the 1s have a contour like this and like this. So that's another number map where the numbers mean density, and now you know 2 different examples of number maps. And as before, of course, we could draw the intermediary numbers. There's probably some 2,000 trees per square mile in between here that would lead to its own contour, and maybe there's a 4,000 contour here, and a 4,000 contour here, and a 2,000 contour here, and so on. I could draw any number of contours that I like. All right.